Hey everybody, this is Larry. This is day 25 of the September Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And today we have triangle, which we will get to. What was I going to say? Yeah, those of you who paid attention to yesterday's video might have noticed that I actually forgot to submit. And you're right, I forgot because when I did submit it, I got a wrong answer because I forgot. I missed the place where I didn't handle the negative numbers, so my apologies. I mean, I don't do it intentionally. I just kind of, I don't know. I think I was just so focused on something that I was like, all right, looks good. And it's 2 a.m., you know. But yeah, thanks for pointing it out. It does happen from time to time. These are all live. It's not supposed to be like me trying to trick you. It's me being dumb. I mean, that whole day, the whole video felt like I was being dumb. So I don't know, right? My excuse is that I just ran 11 miles and I have to do it tomorrow as well. So today is just my rest, chilling, just drinking my water, keep hydrated, and finally, now that I have like some mental time, finally set up my iPhone. Or not even it's not even fully set up yet. It's still like downloading all the apps that I use. But yeah, it's kind of funny because I feel, oh, is this like leaking my detail? I don't know. But in any case, yeah, I was gonna say it's funny because like people make such a big deal out of it being orange, and the orange feels nice. But now with the case, you can tell that like there's a little bit of an orange accent, but I mean it's fine. Maybe I'll put a drawing on the case or something to personalize it a little bit more. But I don't know. That's it. Yeah. Anyways, I'm kind of excited. It's kind of weird. I feel like I'm old now, and nothing makes me feel older than saying that. Like I got this phone. It took me like 3-4 days before I even unwrapped it and unboxed it or whatever and installing it. And now it's gonna take like a couple of hours to like slowly downloading for all the apps. I'm just trying to wait for it to go through like Duolingo, so I could continue my streak. But yeah, but I'm more excited about it, an ottoman that I got for my living room, so I could put my feet up more comfortably. But yeah, anyway, I don't know. People ask me to share more. I don't know if this is the kind of things people talk about, but anyway, if that's interesting to you, let me know. If it's not interesting at all, also let me know. So we'll see. All right, today we have 120 triangle. Okay. Given a triangle array, return the minimum path sum from top to bottom. Okay. I mean, I think this is a pretty straightforward problem in general. I mean, I think this is a problem that, I mean, I don't know. I don't know if it's straightforward. I don't want to say it like that because I feel like sometimes, especially when you're starting out, if you're watching this video, it can be intimidating. All these things are kind of new. You have like 80 billion things that are new to you. So like, of course it's going to look scary. But what I mean is that this is, to be frank and direct, it is table stakes, right? Like these are things that like if you put the difficulty of this problem as like an interview standards, if you will, right? Then the interview standards is probably gonna be like maybe 1 or 1.5 level higher, like a little bit more complicated, a little bit more in depth. So definitely you should be able to kind of think about these kind of problems, and just thinking about and there are a couple of ways you can think about this one too, right? There's the shortest path idea. There's the dynamic programming idea. Whichever idea is fine. You can play around with various ideas as long as you solve them multiple ways as well. That would be something that if you think, yeah, if you did it one way and before you watch this video, try to do it the other way. And even if you did it, see, time yourself, see how fast you can do it. Because I think one thing that I talked about in the past, and I say this from time to time, so it's nothing too new, but if you're new here, then I'll say it again, which is that, when you start solving more difficult problems, even if you have the capability to solve it, you still have to find the time to solve those problems. And to find those time to solve those problems, you have to, solve some of the portions like in a flash, right? I think some of the criticisms that I get on my videos is that why am I not prepared and why am I not whatever. And because at some other times they're like, oh wow, you were so well prepared on these videos. It's like, no. Everything that you see is all my thought process, pretty much. I mean, not my thought process. I have to articulate it, obviously, but like everything you see is whatever, right? Like I don't prepare, because, well, not because I don't. I mean, it's just not the point, right? So my point is that, as fast as you see me getting an idea, and sometimes it's wrong, right? As fast as you see me getting an idea, and you don't have, that's not a reasonable standard, but just to give you an idea of what can be done, right? And that's basically the idea. Okay. With that being said, let's take a swipe at this. It's always going to be a triangle, and the key thing, the first thing to note is just to kind of index them in a good way. You could say a data structure in a good way, or how do you say it? Just like visualization, right? And this one, as a result, is going to be all indexed, right? So if you want to say this is, say, 0 0, then this goes to 0 0 goes to 1 0 and 1 1, and then 1 0 goes to 2 0 and 2 1, and then so forth, right? So that's kind of just like things that you just have to be faster at, right? Because you are going to deal with more difficult problems. So if you're not going fast enough, not to the point of sloppiness, of course. Like, you don't want to go so fast that you make silly mistakes everywhere. It's not about typing fast; it's about thinking fast, right? I think maybe that's the part that sometimes even I make a mistake about. Right? When I talk about working faster, it is getting to a point where you could solve it fast enough so that you don't have to do that much, right? Almost like an algorithm, right? Anyway, all right, let's go. So I'm gonna do it, but I'm gonna just caveat by saying that there's a space optimization one. So definitely, I'm doing it with dynamic programming. There is a space optimization idea, right? I'm not gonna do it in this video. I have a video somewhere. I'll put a link if you reminded me in the comments. Or if anyone's just interested, I don't know if it is, about space optimization, DP, and stuff like that, and step by step. But I just want you to kind of think about it as a result. But I like to for the daily videos, I like to keep it like as simple as possible, just to kind of get started, right? So okay, so the first and also one thing that you can also do is manipulate the input itself, kind of. I tend to not like doing that, just because it's a little bit awkward if you like manipulate it, especially when you're dealing with an array or an array, and you change the elements. It becomes like what are you doing with my data, right? But that's more of an API thing, so I don't know. All right, but yeah. So then here maybe we start with let's just say triangle of 0 0, right? Double checking that triangle have at least length 1. And then I mean, I guess there are two ways to think about this, right? And this is the difference between push and pull. And I know that I always said that there are multiple ways of doing this already, right? So definitely, if you feel like you did this too fast or too quickly and you're just like, oh, this is dumb, this is easy, do it another way. There's so many ways. There's the shortest pathway, which I talked about, and even shortest path, there are a couple of shortest path algorithms. There's DP, right? Even DP, there's top down, bottoms up, right? I'm doing bottoms up. Memorization versus tabulation, if you want to call it that, right? So that's another two ways you can do it. There's space optimization or no space optimization. That's less of a choice kind of per se, but definitely, of course, upsolve that a little bit. And this is this is a relatively simple one, so you should be able to kind of upsolve yourself a little bit. And then the other thing that you can do, which I forgot, what was I going to say? There was one more thing there. Huh. Oh yeah. And this is a little bit more advanced on the bottoms up, is that you can do push or pull, right? DP. And what that means is that, let's say we always said that, if we have, say, 0 0, this goes down, if you will, to 1 0 or 1 1, right? But you can also think of it as the other way, right? Where 1 0, well, maybe not 1 0, but let's say 2 1, say, right? 2 1 comes from well, 1 1 goes to 2 1, and also what's the other one? One one. Well, I mean, yeah, well, yeah, one definitely does, but oh yeah. 1 0, right? 1 0 goes to, so yeah. So I just got a little confused because I was like, did I just say the same thing as here? It's kind of awkward, but I guess that's true because you just look at the visualization. 2 goes to 3 goes to 5, or 2 goes to 4 to 5. But my point is that there are two ways to do it, right? It's like push, and you could say phrase that as push to these, and then you say comes from or pulls from, right? So anyway, I just want to also give you an option there. There's so many techniques, so many ideas. And for this problem particularly, it doesn't matter. But there are other problems where it does matter, right? And there's asymmetry with the DP and stuff like that. And being good at DP means being good at all these things, right? And I know. I just dropped like a house on some people maybe. But I just want to, I'm not, saying all these things to sound smart or something. Maybe I am. Leave in the comments. No. But what I mean is that I just want to give you a glimpse of, this is a simple problem, but there's so many things that you can practice and learn, right? Like there's so much depth that you can go into if you just haven't been able to, right? For whatever reason. So yeah, so definitely, and the best way to learn about or play around with those advanced ideas is to take a simpler problem first anyway. But yeah, and okay, so that's basically the idea. And yeah, and for this one, like I said, it doesn't really matter that much, so that's why I'm like, okay, well, which way should I go? And I would be the rows, and maybe we'll just go, yeah, we'll do a push. So then now, maybe we'll do a pull. And the reason why I changed my mind a little bit is because here we set it up this way. I don't know which way. I mean, it does. Like I said, for this one, it doesn't matter. It just depends on how you set up, and sometimes it just feels a little bit cleaner one way or the other. But then now you have to do dp of I. We will have to append stuff, right? So then you have like for j in range of is it I? So for the first row you have, so how I deal with off by ones is just kind of plug in real numbers, right? Because for example, if I is 1, then j will only have one thing, but if I is 1, we want this to be actually be the second one, which has 2 cells. So then that's why we'll do I plus 1, right? And then here we just kind of maybe just append some numbers. Let's just say 0. It doesn't really matter. It's just a placeholder for me having access to this. And then this is going to be Leetcode 2. Actually, we could, whatever, right? Triangle of ij plus let's actually rewrite this. Let's just say this is infinity, right? And then now we can say, and the reason is because, and for visualization, I always look at a cell. So let's say I'm here, or maybe even the 7, right? The 7 comes from the 4, but there's nothing like on top, right? So that's why you have to be a little bit careful. And so basically, yeah. So if I minus 1 is which it should be, of course, because that always exists. But more importantly, if j minus 1 is 0, feel free to use extra if statements, of course. I mean, like these conditionals, even though this is always true, it doesn't matter, right? If it enables you to understand the problem a little bit better, then it's fine. Then here we take the min of this of itself. Or this plus not triangle, dp, right? 1 j minus 1, right? And in the same way, then now, so that is, if I look at the 5, this is looking at the 3, if the current cell is the 5, then now we have to do 4, which is the other one of if j is less than n, right? No. If j is less than I. This I have to double check in my head. So okay, so that means that if j is 0, 1, 1, then the previous row is going to be I minus 1. So is it just this? Let's try again. I forgot in my head again. Okay, so if I is 1, then the previous cell, or the previous row, so if I is 1, row 1 we have 2 items, and previous row has only 1 item, so then the max j element of the previous row is going to be just I, right? So actually, I think this is fine. And then you would just write the same thing, right? And then of course you can also check that I suppose to keep it consistent, you know. And the reason why you kind of quote unquote keep it consistent is because there is symmetry in some of these things. Like you see the symmetry here, you see it here, and when you don't see some of that symmetry, even though you expect a symmetry, it tells you that, you know, you've done something wrong, or maybe not, but it means that, you know, something's a little bit imprecise. And you know, that's part of the thing about being beautiful code, I suppose. And then now we take the min of the last row, and this should be good. Let's give a spin. Oh yeah, right, I forgot that. I mean, I kind of halfway wrote it, but then I just forgot. So you have to create a new array. Good. Yeah. Well, I halfway wrote this and I moved it in, and I forgot to do it. Yeah. I mean, the thing about test cases is, do these feel representative? I feel like it does, right? So so it should be okay. I mean, the one cell case is there. I mean, you could probably put in more stuff, but maybe I'm just lazy today. Okay, looks good. What's the complexity, right? It's gonna be linear time, linear space, right? How come my thing don't pop up? Wasn't there? Sometimes it tells me I have a streak. I don't know, but I mean, I don't even care about a streak, but I just want to make sure that I submitted it. Okay. It's a little weird. Okay, whatever. But my point is that, yeah, this is linear time, linear space, right? Which maybe sounds confusing, because linear in this case is n squared. N is at least the way that I define n, right? And yeah, because that is the number of things. But remember, the size of the input is n squared, so it is going to be linear in the size of the input, because, well, that's the size of the input. So yeah, that's it. That's all I have for this one. Yeah, hope y'all find this. I mean, this is a little bit long of a video because I talked about a lot of things, but I like to kind of go over some of the basic ideas with, well, like I said, this is a very fundamental problem. And the reason why I said that in the beginning is because, like I said, there's so many ways you can write this. So definitely practice that, and you may not even realize it, right? Like maybe you always write it this way. With the DP, and you're like, oh, I didn't know that there's another way of writing this DP. Well, try it. And again, you can also do space optimization as well, right? Not gonna get into it. Anyway, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.